Hey everyone, this is Mr. Bell making the first of presumably many videos that you'll be watching this year. Sorry you don't have one of these notes packets in person. If you were in school with me you would, but I guess probably just get a spiral notebook and just take notes as you need it and try to follow along. The notes packets, you can find them and print them if you want from my website. But you're going to kill a lot of trees if you want to do that, and it's going to use a lot of printing. So it's not necessary if you print them, but you may want to if you have the resources. Otherwise, just kind of take your own notes and follow along as best you can, and then you can always go back and watch the videos. My completed notes key is also posted on my website, so if you ever just want to skip straight to the answers, you can just go to my website, pull up the notes key from there. Anyways, we're going to start the year with some Precal review material. Most of this should be review, hopefully. Some of it may be a little bit new. But yeah, if you need any help, just always feel free to shoot me an email, and I'll try to respond as quick as I can. Anyways, first example is a typical rational function. And what you should always try to do first is factor. Always, always, always try to factor. This one here is going to factor into x plus 2. X minus 3. The denominator is already factored, so it doesn't need anything else. How you check to see if you factored something correctly, important, right? Because if you don't factor it correctly, the entire rest of the question is going to be wrong. So make sure you have the algebra skills done, but just always check it. Doesn't take too much time. If you just multiply those two binomials together, FOIL them out, distribute, however you want to think about it. But if I were to multiply these two things out, you should end back up with the numerator as it started as. So let's think. X times x would be x squared. Yep, that matches. Then you'd have x times negative 3, so you have negative 3x. Then you have a 2 times an x, so you have a negative 3x plus 2x. Negative 3 plus 2, that would combine to give you this correct middle term, the negative 1x, and then the positive 2 times the negative 3. That does give you the negative 6. So just quickly kind of eyeball and FOIL it out in your head, or if you need to actually do it on your paper, that's fine. But always check your factoring by multiplying or by FOILing it back together, because if you don't have it factored right, everything else is wrong. And here we can see this factor in the numerator is going to match that factor in the denominator, so it's going to reduce. And this rational function is going to end up looking really similar to the line x plus 2. Now this rational isn't the exact same, so be careful. If you were to put an equal sign there, that would be wrong. It's not the exact same as the line. It's like 99.99999% the same, but there's one point that's going to be different. This rational function looks like the line x plus 2, but it's going to have a hole. Since this factor x minus 3 reduced, you're going to have a hole. And that hole is going to be at x equals 3. Just set this factor equal to 0. That's how you end up finding where the hole is. So remember, if you have something that factors and reduces, the value for which it reduces is the hole. So this rational looks like the line. It's not the exact same. There's one point where it's going to be different, and that hole is going to be at 3. But anyways, let's graph y equals x plus 2. So we know it's going to have an intercept here and an intercept here. Slope is 1, so the line's going to look pretty much like this. 1, 2, 3. Has the hole when x equals 3. There we go. Looks pretty much like the line, but it's just missing the 1 point of the hole. The x-intercept you could get by just setting this equal to 0, but here I think we can also see if I've got the graph. The x-intercept is just going to be at negative 2, 0. The y-intercept is also in the equation. 0, 2. The domain, it's almost all real numbers. There's just the one value that you have to throw out. That one value is 3. That's from the hole. So we'll say the domain is all real numbers, but x cannot be 3. And the range, right, it's the y values. The range is also almost all real numbers. There's one y value that the graph never hits, and that y value is where the hole is, right? Everything down here from negative infinity all the way up to infinity, it's all going to get hit at least once by the graph, except this one y value that gets skipped, right? The graph's like, and it skips over. So I need to figure out what that y value of the whole is, because the range is everything excluding that point. Well, it's pretty easy. Remember, here's the line, and this rational function, it behaves just like the line, except it's missing the point. But if I were to plug in 3 into the equation for the line, you get 5. So then you know that y value where the whole is supposed to be is 5. You could also just kind of count it. Remember, this slope is just 1, so it goes up 1, over 1, up 1, over 1, up 1, over 1. You've gone over 3, so you should have gone up 3. Remember, that was at 2, and then this was at negative 2. So you can kind of count it off with the slope, or to figure out where that y value is missing from the whole, you could just take your x value of the whole and plug it in to the reduced version of the function. Okay, so y cannot be 5, and again, that's coming from the whole. Alright, so there's the first one. Not too bad. Don't forget your wholes. A lot of people will miss points on quizzes and tests because of that, but just be careful. Next one, we've got just a typical square root function. It is shifted to the left 3 units. So the graph is going to look something like this. We know the x-intercept is like here, it's negative 3. For the y-intercept, you would just plug in 0. So if I plugged in 0, you end up getting the square root of 3. It's an ugly number, but that's okay. It's a number just as much as the negative 3 was. So it's an ugly y-intercept. That's perfectly fine. The domain, you have this point at negative 3, and then everything to the right of it. Now that's a solid dot, so you would want to include it. So I'm going to write this here in interval notation. Negative 3 to infinity. Always, always, always put your parentheses on your positive or your negative infinity, right? You never quite get there, but you head in that direction. But you would want a bracket on the negative 3. Bracket means inclusive. Another way of writing it, you could write negative 3 less than or equal to x less than infinity. I think this is just mildly less writing. It's a little bit faster, so I will typically write my intervals like this, but this is the exact same thing. Again, the bracket means inclusive. You have the equal to bar, the parentheses means exclusive, no bar. Range is everything from 0 all the way up to infinity, and since that's a solid dot, you would include the 0. Again, you do not have to put both. Either one is fine. I typically like this notation just because I'm lazy and it's a little bit less writing. So the first two should be pretty quick. Now we're going to look at this next one, which is probably the first one that you may have a little bit of difficulty with. And to kind of see where this graph is coming from, let's go back and hit a little bit of geometry. If I had an equation like this, that's something called a conic section. It's kind of the nicest conic section. That's just a circle. X squared plus y squared equals r squared. It's a circle with the radius of r. And then that would be centered at the origin. In general, if you had some other circle like x minus h squared plus y minus k squared equals r squared, that would still be a circle radius of r, but this one would have the center hk. So going back to a little bit of your geometry, this is going to end up being sort of like a circle, but let's see, if I started with x squared plus y squared equals 25, right? So that would be a full circle with the radius being 5, right? So that would look just like this. You go up 5, down 5, left 5, and right 5. But here we need to solve it for y. So let's think about it, just kind of 2 steps. Subtract the x squared over. And then I need to get from y squared to just y by itself. And to undo the square, you just square root it. Be careful, when you physically square root something, you need to think about plus and minus, right? 2 potential solutions. So again, all of this stuff right here, that's the full circle. X squared plus y squared equals 25. That's the full entire circle. So this equation, y equals plus or minus, that's also the full equation. But here we don't have plus or minus. Here we just have the plus, right? So you could think about this as breaking down into two smaller parts. You could have the positive part, which is the positive root of 25 minus x squared. And if you have positive y values, that's going to not be the whole entire circle. Positive y values would only end up being the top part of the circle. So something like this is a semicircle. And specifically, since we only have positive y values, I know it's going to be the top part of a semicircle, or the top semicircle, the top part of the circle. So the radius is still 5, the square root of the constant. So go 1, 2, 3, 4, 5 up, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5 to the left. And again, if you had something like this, you would graph the whole circle. Or if you had something like this, you would graph the full circle. Or if you had something like this, plus or minus, that would be the full circle. But since we only had the positive root, we would only want, oh, come on, pencil, we would only want the top half, right, the positive semicircle. If you would have had, right, that was the top, if you would have had the negative square root, 25 minus x squared, right, so if you had only the negative side, the negative y values, that would be the bottom part of the circle. So it would still be a semicircle. Well, you wouldn't have the crossing diameter in the middle, so just the edge. But if you had the negative square root, that would be the bottom, because that's the negative y values. You could also do stuff like this. X equals, or I guess we'll do x squared. No, it's just x, my bad. X is going to equal, how about if we did 25 minus y squared? It's still starting with this equation, the full circle, but instead of solving it for y, we could solve that for x. But if I only had the positive x values, what part of the circle do you think it would be? Positive y values is the top, negative y values would be the bottom. Positive x values, it wouldn't be a function anymore because this would fail the vertical line test, but something like this relation, this graph, it would end up being a semicircle, but it would be the right side of the circle, right? Positive x values means you'd want the right, or if you had the negative root of 25 minus y squared, negative x values, that would also still be a semicircle, but it would be the negative x values, so only the left side of the circle, so it would be the left. So that was the right, and here we have the left. We don't typically deal with stuff like this because they're not functions, and we really only care about stuff that's functions. So we could potentially see the positive, the top parts of the circle, or we maybe see the negatives. But you're going to need to recognize this going forward, right? Something like this, you may not know that it was a semicircle coming in, but after having gone through it, you should be able to recognize it in the future. All right, so once we have the graph, everything I think is pretty easy. The x-intercepts, there's two of them. You've got the negative 5, and you've got the positive 5. The y-intercepts, there's only one of them up at the top. The domain from negative 5 to 5, inclusive on both. The range from 0 to 5, also inclusive on both. Okay, so semicircles, probably a little bit new. Going forward, though, you need to be able to recognize them. And I believe I'm only allowed to make videos that are 15 minutes long with this free software. So I'm going to go ahead and pause and then switch it over and then hopefully pick up with the next example in the next video.